What are architecture components in Android development?
Android architecture components are Jetpack libraries like ViewModel, LiveData, Room, Data Store, and Navigation that support clean architecture patterns such as MVVM. They help separation of concerns by keeping UI logic in the ViewModel, managing lifecycle-aware data with LiveData, handling local storage with Room, and simplifying navigation. This leads to scalable, testable, and maintainable code.
How do you manage background tasks in Android?
I use Work Manager for deferrable and guaranteed background work, especially tasks that must run even after the app exits. For immediate background tasks, I use Kotlin coroutines with dispatchers.io or Lifecycle scope. For continuous or scheduled background tasks, I also use Alarm Manager or foreground services when needed, especially for tasks involving user-noticeable operations like recording or tracking.
What is dependency injection in Android development?
Dependency injection is a design pattern that provides a class with its required dependencies from the outside, rather than creating them internally. In Android, tools like Hilt or Dagger automate this, promoting loose coupling, better testability, and easier code reuse. Dependency injection helps manage complex object graphs and keeps code clean and scalable.
What is the difference between Dagger and Hilt in Android development?
Dagger is a fully featured dependency injection library but requires a lot of boilerplate and manual setup. Hilt is a wrapper built on top of Dagger, designed specifically for Android. It simplifies setup by providing predefined components, Android lifecycle integration, and better developer experience while retaining Dagger's performance and flexibility.
How do you handle different screen sizes and resolutions?
I use constraint layout and guideline, % or barrier to build responsive UIs. I define multiple resource qualifiers like layout SW600dp, drawable MDPI, HDPI, XHDPI for supporting various screen densities. I also use vector assets for scalability and test layouts using the layout inspector and different emulator profiles.
How do you manage app security like sensitive data, API keys?
I never hardcode API keys. I store them in native code using the NDK or retrieve them securely from a backend. For sensitive user data, I use Android's encrypted shared preferences, Jetpack security, or keystore for encryption. I also enforce secure networking using HTTPS and verify SSL certificates if needed. I obfuscate code using ProGuard or R8 during release builds.
What's your approach to unit testing and UI testing?
I write unit tests using Junit, Mockito, and Truth for ViewModel and repository layers. For UI testing, I use Espresso and UI Automator. I follow TDD in critical modules. With Hilt, I inject fake dependencies during testing. I also run tests in CI pipelines using GitHub Actions or Bitrise.
How do you handle data caching and offline access?
I use Room for local caching and Data Store for small key value storage. I design a repository pattern that checks the local cache first and fetches from the API only when needed. I also implement cache expiration, sync logic via Work Manager, and show cached data when offline, enhancing UX with a seamless offline experience.
Explain the lifecycle of an Android activity.
When an Android activity starts, onCreate is called, where the app sets up the screen and gets everything ready. Next, onStart makes the app visible to the user. Then, onResume brings the app to the foreground, making it fully interactive. If the user switches away or a call comes in, onPause is triggered. Here, the app is still partly visible but not in focus. When the app becomes completely hidden, onStop runs, allowing the app to save data or free resources. Finally, when the app is closing, onDestroy cleans up before shutting down.
How do you implement real-time updates in Android?
For real-time updates, I use Firebase Real-Time Database, Socket.io, or WebSockets depending on the use case. For local real-time UI, I use LiveData, Stateflow, or RxJava with Room's observable queries, Flow. These keep the UI reactive and update instantly upon data changes.
What's your strategy for handling configuration changes?
I use ViewModel to retain UI-related data. I store transient UI state in saved state handle or use Jetpack saved state registry. I avoid onSave instance state for heavy data and leverage Android config changes only for specific cases. For Compose, I use Remember Savable.
How do you handle memory leaks in Android?
I avoid leaking activity, context into long-lived classes. I use Leak Canary to detect leaks and fix them by using weak references or application context. I also remove callbacks and observers in onDestroy, or in view models on cleared. Proper coroutine cancellation helps avoid leaks too.
What's the difference between LiveData and stateflow?
LiveData is lifecycle aware and is part of Android Jetpack. It's commonly used with XML-based user interfaces. Stateflow is a Kotlin native tool that supports flow operators and offers more flexibility. It works especially well with Jetpack Compose. In new projects, I prefer using Stateflow because it gives more control and fits better with other flow-based APIs.
What is the repository pattern and why do you use it?
The repository pattern abstracts data sources and allows separation of concerns. It provides a single source of truth by combining data from local room and remote API sources. This makes the code testable, scalable, and easier to maintain.
What is Jetpack Compose?
Jetpack Compose is Android's modern UI toolkit that lets you build native interfaces with Kotlin code instead of XML. It's declarative, so your UI updates automatically when data changes. With less code, built-in material design, and full Jetpack support, Compose makes UI development faster, smarter, and more fun.
How does state management work in Jetpack Compose?
State is at the core of Compose. I use things like remember, mutable state OF, or stateflow to hold UI data. When the state changes, Compose automatically recomposes only the affected parts of the UI. This reactive model makes UI updates efficient and clean, reducing the need for find view by ID or manual notify dataset change.
What are the main features of Kotlin, and how is it different from Java?
Main features of Kotlin are null safety, extension functions, coroutines for asynchronous programming in smart casts and type inference. Kotlin differences from Java because Kotlin has a more concise syntax. It offers better null safety and can be interoperable with Java.
What is the difference between lazy and latent, and how do they affect memory storage?
Lazy initializes the property only when accessed for the first time, used with val. Latent used for var. The property is initialized later, but you must initialize it before accessing it.
What are coroutines, and how do they work in detail?
Coroutines are a way to do background tasks asynchronously in Kotlin, like downloading data, reading from a database, or waiting for a response, without blocking the main thread. Coroutines is lightweight threads, but faster and more memory efficient. They can be launched using launch or async. They run in the background using dispatches, like main, IO, or default. They can be paused with suspend and resumed without freezing your app. They help to write sequential-looking code for asynchronous tasks.
What is the difference between dispatches.io, dispatches.main, and dispatches.default in coroutines?
Dispatches.io is for background tasks like reading files, database access, or network calls. Dispatches.main is for UI tasks on the main thread, like showing data or handling user input. Dispatches.default is for CPU-heavy work like calculations or data processing, done in the background.
Thanks for watching. I hope these questions help you feel more confident in your next interview. Don't forget to like, comment, and subscribe for more career tips.